Welcome to Study Loop.
19.63. So we have a circuit set up here. We have a battery with some internal resistance, and then we have two identical resistors in parallel or in series connected to that. And additionally, we've connected an ammeter and a voltmeter that each have resistances associated with them. So we want to figure out what the ammeter reading and what the voltmeter reading will be, and what the sort of percent error is for both of those, as opposed to if they weren't present in the circuit. So the total current through the battery here is going to be the EMF of the battery divided by the equivalent resistance. So the equivalent resistance, we have the internal resistance of the battery, we have the internal resistance of the ammeter, we have our resistor here, then we have the parallel, that's in series with the parallel combination of our other resistor and the voltmeter. So R times RV divided by R plus RV. And this works out to be 12.5 kiloohms. So then our source current is 0.96 milliamps, or 960 microamps would maybe be a better way of expressing that. So this is going to be the ammeter reading. And then the voltmeter reading is going to be the reading, is going to be the voltage produced across the parallel combination of our resistor and the internal resistance of the voltmeter with the source current flowing through it. So we're going to get source current times the equivalent resistance here, and yeah, so that will give us 4.8 volts. So then if there weren't any meters in this circuit, then the equivalent resistance would just be the series combination of the sort of resistances we want. So 2 times our resistors here plus the internal resistance of the battery. And so this would mean that the source current would be 800 microamps. And then the voltage across one of the resistors would be this times its resistance, which would be 6 volts. It would be slightly less than this because of R, but like this is 1 ohm compared to over 7,000. So then the percent difference for the current is plus 20%. So this extra resistance in parallel here decreases the resistance of all this enough that the current is higher than it should be. And then that results in more voltage drops before you get here. And so your voltage reading is low by 20% with the voltmeter and ammeter in place.